The panel discussion really is to get a deeper understanding of the project, which is a prestigious project and a winner in the commercial category in the SSMB awards. So I will in fact focus on trying to get a little bit more understanding on the thought process behind the project more than the actual project itself. The actual project details will be covered by Kalyan, but my questions are going to be more on the thought process, and not just for the construction, it's also for the maintenance of the building and the end of life cycle, what happens to the material used. So without any further delay, I'll invite Kalyan. Kalyan, I think you have a presentation, right?
Yeah, we have a small presentation.
Yeah.
Just make sure that people are aware about it.
Sure, I think that'll be a good start.
So, yeah,
Kimi?
you can.
Good evening, everyone. Thanks a lot for giving this opportunity to present our project, which has been selected as one of the top projects in tall building category. We today want to present a project which is Phoenix BHUB Tower 1. We have presented this project under tall building category. On 21st to 24th, we have an SSMB awards function which happened in Bombay. We presented this project there. So, coming to brief project details, the built-up area of the project is about 1 million square foot. Floor designation 4 basements, ground plus 29 floors plus terrace. Grid and floor height 11 meters center to center, 4 meters floor to floor. Objective, it's a grade A office building. Object scope, warm shell specifications, what we have done from Phoenix, building height 150 meters. We have other stakeholders part of the project, which is Turner International as a program manager and building design consultant, Chapman Taylor, structural consultant, Stratcom from Pune, general contractor SPCL at the time the project was completing, and then steel fabrication and erection, JSSL. So this, from our perspective, this building at the time when it was conceived to be developed, we had a vision in mind to have a unique and iconic building at that location on 100 feet road, which is then proposed by government of Telangana. So this is a project which is located in Gachibowli. In fact, from this location onto my right side and onto your left side, right in front of this Hyatt as a hotel, you can see this building from outside. So this is a campus which is about 17 acres, and out of that we have about 5 buildings originally proposed for the 6 towers which are originally proposed, and out of which Tower 1 and 2 have been completed presently, and Tower 1 is what we are discussing. So this is a front area what we have, and this is Tower 1, and we can have a view of building which you can see as a floor plate, having a core wall which is eccentric, and we also have 2 cores which are coming on either side. This is a side core building, and we have cores. You can see the lift cores are on side. We also have service core, which is service lift and service staircases on the right side. So this is the overall campus view originally viewed as, and this is the tower what we are discussing, which is Phoenix Business Tower 1. I would like to. Yeah, Prasad, you can.
So yeah, Kalyan just gave a brief about the, should I go that side? I think it's better to sit. This will block the view. So this is a high-rise steel frame building, and when we say it's a completely steel frame building, the highlight of one of the major highlights of this building is the RCC shear walls are actually constructed with steel shear walls. So, we have a steel sandwich plate connected by shear rods, and then only infill concrete has been, poured into the walls, just like we do for the CFT columns. So that is one of the main USPs apart from the CFT columns. So if you see, there is very minimal RCC works going on, or the civil contractors work, form work, rebar is almost negated by 90 to 95%. So it's mainly a steel contractors work to go up as per the speed. The walls, if you see one of the highlighted point, we are bringing walls or steel shear walls for two levels. The floor height was 4050, so the two floor height becomes 8.1, and the panel width was 2.3. So, the trailer width that we have in India is typically 2.4, and the length we can go up to almost 12 meters. But since the floor height was 4050, we bought these panels in 2.3, stitched them on the ground with bolted connections, and then lifted an entire core wall. If it's an elevator shaft, then, an entire C or an L was lifted and erected on the top. So this is the typical structural layout for the building. As Kalyan mentioned, the cores are eccentric. So there is a major core on the left hand side. You see the elevator cores. So those are formed in steel frame, and there are two little staircase and elevator blocks on the two sides that help in torsion resisting of the building. And go back. Did you flip it? Okay. So the framing also is very unique. The columns have dual beams on either side. So the floor depth was of importance for Phoenix to achieve a clear height below the 4050. So there is a CFT column, and if you see, the two lines are the two main beams. So basically, instead of a central main beam, which in the secondary beams go into connect to, we have these two main beams. So they share the load, and essentially the depth can become equal to the secondary beam. So that is one of the key design aspects that Studcom innovated on the steel shear walls and CFT columns. This is a shop drawing of a steel shear wall. The one on the right is the fabricated and erected piece of two walls. And this is how, a single panel of 2.3 by 8.1 meter looks. And the cross section on the side where studs or, rods are joined. So that actually connects and engages both the plate. So this essentially is the rebar for RCC shear wall. And then only concrete infill is done. It works extremely good in lower seismic zone like zone 2 and zone 3. Where we can actually analyze this in even ETAB. So ETAB support this kind of construction because it's a known technology and a proven methodology in the US and UK. They call it steel shear walls or bi steel core. Some other side pictures, as you can see, we brought the walls in two lengths. Some connection details of the column and the beams of the dual beams, as you see, even to reduce the beam depth and to get the structural steel economy, these main beams were moment frame beams. So you see a box column, the magenta color and the yellow color beam. The yellow column is coming with 4 gray color stubs, which are the stubs for the main beams, and then we go and splice them on the side. So this further gives economy in terms of consumption and also the floor depth. And certain services also pass through these beams. Some pictures from the Tekla model. So this is again the steel shear wall. You see those dots on the shear walls are actually bolts which we bolted on the ground. Each panel was 2.3 by 8.1. But since the tower crane capacities were good, decent, almost 5 to 6 tons, we could stitch them on the ground on a frame and then lift it and then erect it. Even the horizontal joints are bolted, but to have the shear transfer properly, we also welded those joints to be doubly sure. Some more pictures, and the picture on the right shows the concrete pore hole opening. So this is the inside of the shaft. Some other pictures how we stitched the walls together and erected. And a little bit about the logistic plan, how the 4 tower cranes were placed. You see the picture on the south, the 4 colored circles are the tower cranes. So the 4 tower cranes closely spaced, being luffing cranes, was, the precursor for the speed to be achieved, which, Kalyan will talk about. So the number of elements drove the speed.
Thank you, Prasad. So coming to the project in terms of key parameters and construction technology, again, foundation is a conventional approach what we have gone with RCC and PT slabs. Tower area we have gone with composite steel structure, as Prasad has already mentioned and explained, and we were able to get about 8 days as a vertical slab cycle in this project. In fact, here I should just add a point that because of the tower cranes and jumping, and in terms of further delays in terms of jumping those tower cranes to the further heights, our average is coming out to be 8 days, but then at places we also achieved about 7 days, which is for 2 floors, which is about 3.5 days slab cycle. So effectively it is possible to do at 3.5 days is something which I want to insist and mention here. And column in CFT beams built sections, combination of plates in E350 and 450. As an organization, our development approach has been that the efficiency in design and execution are taken by and large to the understanding while we design, and 450 has been our main material usage in our projects, and here also what you can see that 450 grade has been used. Core walls is again steel core walls is considered concrete boom places and tower crane for slipping. Facade unitized system, tower cranes, luffing cranes, 4 numbers. Mobile cranes and feeding cranes along with deck riders on the floors have been used to get the efficiency in terms of execution and timelines. Partition walls, fireproofing, again, partition walls also we avoided civil work, we have gone with robomatic panels to get more modular approach towards the construction. And fireproofing, again, columns in intermittent and beams in vermiculite have been used. Start 16 May, roof top out by 10th April. And we mentioned in between restart, that is because of COVID, we lost certain amount of a time. Effective 11 months for 35 slabs. And fire NOC requirements we have achieved despite of the challenges. And we have several challenges at that point of a time, right from oxygen shortage, fabrication delays because of COVID, lead time of material, labor shortage, COVID restrictions. Still, we were able to achieve this. This is only possible because of modular construction and steel construction, because everything is done at factories and fitted at site. And that's an advantage what we get through steel construction. So this, what you can see, one of the early images of the project where while we have just started with an extent of basement and few floors on the lab, and this is something as a core building once it is completed by and large for the structure. So this is a present images of building which is completed, and we'll be happy to take you guys there to side if someone is interested to come, we can take. It's hardly any distance from here. And in fact, right from this location also on to the outside, you can have a view of the building. So this is Tower 1, what we are discussing. This is completely done in structural core wall, and the other one in RC, but then this building is what we were discussing now. So challenges, raw material, high cost on steel consumption in reference to RCC, lead time, issues, limited fabrication capacity in the country at the time when we started. Now there's a lot of capacity built up has come into the market. A lot of companies have come. There's production capacities which by and large got increased. Your supplies have got very smoothened up. But at the time when we started, we still had those challenges. Require high capacity of cranes. And we can say in the entire gamut of projects what is happening, luffing cranes are by and large not being used effectively everywhere, but the amount of difference what we can see in construction we have seen in these projects, and thanks to JSSL for their understanding of project requirement and insisting upon that, and then we got them placed onto the projects for the execution. And technical know-how in the industry also, few years back, I would say about 5-7 years back, it was very difficult. And when at a conceptual stage when we are discussing, it was very difficult to have that knowledge coming on the table to discuss and get things aligned. So risk mitigation strategies, again, we go by our design as no change approach. That is one mitigation strategy which requires largely for a project with a faster timelines. Teamwork and empowerment, risk assessment becomes part of our process along with the mitigation. Pull planning, because we have Turner on board. Closer look on supply chain. GC is made responsible, so we go with larger GCs like in this project SPCL, and we go with L&T, we go with LEET, and these are the kind of companies whom we work as a GC. Exclusive monsoon preparedness plan. This is to envisage future in terms of what it can be and get prepared for it. So safety measures, again, there's a standard safety measures what we take up in the projects. Quality measures, approach towards our quality insurance, and this is, but anyways. So last but not the least, setting up new benchmarks. Phoenix Group as an organization, we wanted to always become a market leader in whatever we do it. And that is one of the reasons why we have been constantly churning in terms of our technology, what we adapt in our projects. And we always consider efficiency, customization, and sustainability our prime approach for our development, and we see steel structure is completely aligned with our requirements. That's come 60% of built in factory. You have 40% on site, which is primarily assembly, and 98% recyclability, includes net usable area, tailored solutions, environmental friendly. So these are few advantages what you have on steel structure. And I keep this forum open for discussion. I give it to Mr. Ruchir, please.
That's yours. Okay. Thank you for a very insightful presentation. You've mentioned a whole lot of figures and numbers, but before we start on that, whose basic idea was it to choose steel as a construction material?
It's a very easy answer for me, and it's our CMD, Mr. Gopi Krishna Patiman. So he's the one behind this choice of getting into this material. I would say the entire organization is lined up with his thoughts and as a vision by the organization. Our Emeritus Chairman, Mr. Suresh Chukkapalli garu, has a vision to make Phoenix as an organization which becomes industry best in terms of whatever we do. We have done in the past with developments which are in precast. We have a combination of precast and RCC. We have done buildings which faster in RCC as well. But then the pursuit of time has always been there. So at the pace at which we are going today, it is mandate to have a technology which comes in alignment with the thought process of time, and also a quality which can have no second. So that's a way, and it's a thought process by Gopi Garu to have this taken up. And we almost spent about a year and a half in evaluating various options before even we got into first project to start with.
Okay.
So that 1.5 year time, what he spent evaluating has really helped everyone to get along with.
Wow. So you already answered my second question, which was, did you do any analysis? So if you've done a 1.5 year analysis, what were your key findings? So typically just to give you a background, to give everyone a background, typically we always found at the very least, a steel structure would be 20 to 25% more costly in terms of construction costs. And subsequently all the other time savings and everything else kind of, comes in later. The initial discussion with the developer was always on the initial investment and capital cost. The other thing was cash flows. For a developer to build in a conventional system is much easier because he doesn't have to put all the money up front. And in steel, you do need to put money up front because you are buying the material right in the beginning. So your cash flows are also different. So what were the analysis? What were the figures? What happened? What came out of that analysis of 1.5 years?
So to my best of knowledge, the thought process has been always that, yes, there were a lot of studies been done. Studies been done in terms of various technologies, which also included the precast complete building, RCC complete building, using core wall with something else, and you have other shuttering systems for balance slabs. Steel, again, combination only steel, RC wall with steel, or steel alone with steel, and complete building with steel, or only tower area with steel and non-tower area with non-steel, which is an RCC and PT. The combinations of time and cost, when we get in, cost is anyways high. Now, time is something.
By what percentage approximately, as per your findings?
Cost, what you're saying? I would agree with what you're saying, about 20% plus or minus here and there.
Okay.
It will have a cost for sure. But bringing in efficiency with the experience, that difference certainly has a difference to what in the market has a difference. I would not say that is the same difference what you get in every project. So the layout what you're choosing, the core location, the grid size, the various other elements what you're actually requiring part of the project will certainly make a difference.
Sure.
So the load also has to come down. I'm saying you put a lot of block work on a steel structure onto the periphery, everything gets added on the dead weight. You have a lot of things which are coming on the building I'm saying, assume if it is a data center, again, it has a different this thing. If it is not data center, if it is a different. So on a typical IT building with 11-meter grid, and for a 30-story building, it would land between 15 to 20% what it gets in with. Okay. So the cost is already there, but time we can certainly, I'm saying RCC, if I'm not wrong, would not come anything less than 20-25 days as a point of a minimum this thing, and it's labor intensive. I would say it is not that it is not possible to be done in 10 days or 12 days, but it is labor intensive and consistency at a pace today. You have about 30 floors to do. Getting a consistency of that 20 days or 15 days consistently for 30 floors is something very difficult in RCC. So I am sure there was a time when we started development in steel. We were alone been doing steel in Hyderabad. Now we can see a lot of synergies coming in across with the developers where people are converting to get into steel. So that itself shows that the requirement of less labor force intensive work. Second, logistics is a huge constraint. Oh, yeah. So you need to have space, unlike few decade back, you could have, I'm saying at least 10 years back, you could have seen that in terms of space availability is much bigger. You could have had a lot of material spill over around the sites. Now you have exactly site, you can't even have the tower crane which is moving out. The restrictions from the government, from the local authorities come so strict that you can't have a pointer coming out of your tower crane beyond your project site. So it becomes a mandate for us to plan things like that. So that really helps in steel structure. So all aligned as a vision by the organization, having all our properties in that prime location where hardly have any logistic support around. So it also becomes for us to plan it ahead that this kind of approach is taken in. True. I think that is one of the reason what I would say.
Good. I'm glad you mentioned about labor intensive. See, for a tall building, most people don't understand that movement of labor to the required area of work itself takes time. And it's a logistic issue. Because if you have even hoists and you've got 300 workforce and 200 of them are going to be at some level, spread over 3 levels somewhere, to get them to that and get them out itself takes hours. And that is all cutting into your work time. And that if you replicate over a period of time, say a year, it translates to a lot. So it's a loss of timeline itself, and it's a cost. The thing that was going on in my mind was the floor height, which is 4.05. Right. Now, 4.05, can any one of you all tell me as to what was the, what governed that particular height? Was it an overall restriction of height of the overall building, and you needed to fill in existing number of floors?
There are two things to it. One, industry standards. Mm-hmm. So when it comes to an IT building or a commercial office space, 4.05 has been always considered to be a grade A office building heights as per the set rules of IPCs.
Why not 4.2?
It can always be better. It can be at 3.9 also, provided the kind of structure detailing what you're doing, where the beam itself has provisions in beam for services, then you can still reduce it. But the effective all guideline comes in as 2.85 is a false ceiling height what you should get. Okay. So when you have a cap at false ceiling height, and then the plenum what you have on the top is what it governs the minimum what it. Now yes, height is one aspect which comes on Airport Authority of India in terms of its clearance of height. But beauty in Hyderabad is we don't have FSI, so I don't have to really worry about FSI in terms of height, as far as it is not coming in the funnel of airport this thing. So the second guideline comes as per the local authority norms is about the road width. Okay. So here the development height of the building is directly proportional to the road width what you have. You have 100 feet height, then you have about the unrestricted height possibility. While that is said, there is also another rule which says for every 5 meters of a setback increase beyond 45 meters, there is about 0.5 meter of a setback which increases. So automatically the guideline has been done in such a way, the taller you go, the space around automatically gets cleared by itself with the setback. So the effective, it's another way of FSI and FSI rule,
Yeah.
but here you don't have that restriction, so the larger sites you can go tall.
Okay.
So that is possible. So when you have certain height and then you have your false ceiling height, and then you get to that sweet spot of optimization of your column, everything, I think there fits in with 4.05.
So clear height was 2.85, but I'm sure you manage more than that. Yeah. Because
Again,
4.05 with the beam depth that you were talking about in the presentation, 450.
So
Yeah.
that's with the duct.
So
Yes.
yes,
The false ceiling.
of
Yeah.
course, I'm saying false ceiling, bottom of false ceiling is what I'm saying, is what has been put as a bare minimum. Now,
Okay.
we get up to 3.3 inside, except at the AHU
Yeah.
area.
That was the
So,
HUI.
right, that's a minimal thing what I was saying. Yeah, that's a minimal height what I was mentioning. I'm saying nowadays we are seeing large requirement from the end users coming without false ceiling. So they are much happy to have it industrial look.
Yeah.
They used to create this industrial look in RCC. Now they have got actual industrial look, so they're very happy.
That's good. All right. So any challenges, I open this to JSW, JSSL as well as to you guys. Any challenges during the construction which you foresaw and it did happen and you took care of it, and how?
The biggest challenge we had was the timeline that Phoenix wanted it doing, and that's why there was all a challenge. We had to put 4 cranes in a very small area, which
Okay.
the building is only 45 metres square. So to getting all 4 cranes working efficiently, that was the challenge. And also the capacity of the cranes. We worked close with construction team and our design team, worked very close together to make sure that what comes to site can be erected fast, quickly. So, Prasad already mentioned in the presentation, the shear wall panels, they came with the right size, so we knew how many we could build up together to erect in big lumps to achieve the programme what they was after.
And how did you manage simultaneous operations of all 4 cranes? Because obviously you made
I
levels.
made sure they all slewed one way. So one would pick up from there and erect there. He would pick up from there and erect there. And it worked.
Oh wow.
And it worked.
Okay.
It worked very good.
Direction.
Yeah.
ACD,
Yeah.
device will stop taking.
Oh yeah, that
Not
will be.
moving in clockwise or anti-clockwise.
So we had to bring the steel in the right sequence to make it work.
Oh wow, that's great.
So, yeah, it was good. It was an enjoyable project actually.
So you also mentioned in one of your presentations you had floods in Hyderabad. Now,
Yeah, we did, big floods.
Now,
Yes.
I have 2 questions related to that. What if it was a conventional building? What would have happened in that scenario? And the fact that, of course, you were building in steel. So how did that help? The choice of material help?
I would say it would have not made much of a difference at that point of a time whether it is steel or an RCC. But after that, at a pace what we have completed the project would have not completed if it could have not been a steel.
Oh,
I'm saying material wise it is never done at site. Material wise is all fabricated in factory and it is delivered at site. We had a situation where the supplies were slightly more at site, and because of the floods what it came in, there was an access which was restricted because of the water which is logging in. But then we cleared out hand networks created to see that those accesses are recreated, and we were able to pull it out. Yes, but that was like one of its kind. I think the entire zone got flooded. It could have not been a situation where somebody could have thought, yes, we could have got out of that. That was not the case. It was too heavy, and yeah.
oh wow. So, and your, now, I saw from your presentation a whole lot of project management systems and processes. Did you use BIM for real-time monitoring, or to just kind of do a review of what the project was at, which stage the project was at? So did you have any such kind of real-time monitoring to see if you were on track or not?
Not on this particular project, through BIM.
Okay.
We've since instigated that. On this one, it's old-fashioned.
Oh, it was
monitoring.
old-fashioned.
Yeah.
Okay.
So it was mentioned in the presentation, but Callian briefly went through it, which is the health and safety. So while we were putting a lot of pressure on JSSL to install quickly, we still had our health and safety rules to follow. So that was one of the major challenges that we had to make sure that they didn't hurt anybody.
Any points? Just
See,
touch.
although we have not gone with BIM, but the approach has been, we had pull planning, which has been on forefront to understand every sequence of activity for the project, analyze, understand, plan, mitigate, and then go with the development. So the kind of development what we have gone into the market was so huge, so many projects happening at a point of a time. So it is mandate to have process in place.
Yeah.
So we have got tied up with Turner International. So Turner and Phoenix, we have a program management office. So this office of program management office deals the entire construction, and they manage this entire planning.
But they would manage across multiple projects that are going
They
on
only do
simultaneously.
for Phoenix. This Phoenix PMO is only, Phoenix Turner PMO is only specific for Phoenix project.
But all of Phoenix's projects would be managed together, or only one?
Yeah, they managed
one?
as a program management. So
Okay.
we have independent teams under them, and then we'll have a program director who is then managing the projects.
That's very efficient, because you
Yeah.
can always pick resources and put it to wherever else.
Right.
there is.
So it was planned in such a way that it has a matrix organization. It has all the functional heads on vertical silos, and we had project heads on horizontal silos. So these interface with the functional silos and project silos interface, and headed by a program director. This is a project approach dynamics which have been created, and that's how it was taken.
So I'm now going to ask you a very, very revealing question. While you were doing the project management old school, did something go wrong? And how did you address it?
COVID, obviously.
No, something else.
COVID and the floods were our two big ones. You get day-to-day operation issues. Every project does. For BHUB, for Tower 1, no, there was no major concerns.
Okay.
So it's not just health and safety, it's quality, and it's all of those normal project management techniques. But I can honestly say, no, BHUB 1 went really, really smoothly. BHUB 2 was a little bit different, but BHUB 1 went okay.
No, but you had no issues of somebody in the team dragging you and holding you back, and you having to have them pull up.
Every single one of them. While we had the general contractor SPCL for the majority of the time, after COVID, Phoenix took over managing of individual vendors rather than having a GC manage them. And that's where you have all those issues. So every vendor has their own priorities, which is fine. And in the most time, they go in very different directions. So it's your job to make sure that they are all moving generally in the same direction together. Time was a big factor for us. It's a big factor for us all the time. And forgive the pun, but trying to make sure that everybody was aligned with the time was probably the most significant amount that was taken up by. Cost, not so much. It is always about getting the product to market as quickly as possible. Hence, structural steel we picked when Gopi looked at the various options. It came down to, and I know you mentioned about upfront payments. It's not just about upfront payments for a developer. It is getting it to market and getting money in also.
Yeah.
So the cash flow and the financing are a huge cost that we have to try and get down. Using structural steel and getting the time frame down is a large part of that. So yes, there might be an additional percentage upfront, but you make more than enough at the back end to take care of that. Yeah, that's...
So overall, in terms of, since you spoke about the pricing and the cost issue, overall it does make sense because A, you freed up a lot of net usable carpet area with smaller footprints of columns and structural elements. B, you got your returns faster because you completed the project and you got money back and sales happened. Typically, with developers, it's always been the case that they say, hey, listen, we are not bothered about time. Over a period of time, I mean, there was a time when real estate was just going up and up and up. So he says, okay, so if the building gets delayed by 3 years, it's okay, the selling price would increase. But that's not the case anymore, right?
No, certainly not, because there's a lot more financial institutions that are loaning for developers. Okay. So previously, developers would self-fund the buildings. Once financial institutions get involved, then the repayment schedule that you have to do with regards to the loans, that's what you have to start reducing as soon as possible. Yeah. So the quicker the buildings go up, the quicker we satisfy the conditions from the lender, the quicker we start getting clients into the buildings. It's good for us.
So, Kalyan, this building is leased or it is sold?
No, it is not leased yet. So, under discussion as of today.
Okay. So, there's been no sale or leasing as yet. What's your plan?
See, it is in the market for leasing. And largely the kind of clientele what we have, we go with the larger floor plates and in terms of number of floors and kind of, although buildings are always designed for disability in terms of the floor plate, but we largely go with clients with a bigger floor requirement, area requirement. So yet we have not got someone for this onto that.
Okay. The reason I asked that question is simply because when you are an owner of a building for a longer period of time, then you look at the operational costs a lot more seriously and more in detail, because it's going to impact your bottom line.
Yes.
And the other advantage is when the real estate prices go up, ultimately you even benefit because you've invested a little bit extra right at the beginning, upfront.
Right.
So that's where the ownership model and the lease-based model especially for commercial buildings, because markets are very dynamic. So that kind of makes sense. That's what
That's true.
Proud. But sale helps in one way because whatever money you put in, you've got your profit and your costs back very soon. So that's the other aspect of it. But sustainability, operational efficiency, everything comes in a lot more seriously. It becomes a serious part of your
I agree with you.
thinking process if you're an owner. Okay. So the last question which I have is, you were talking about 98% recyclability. What exactly you mean by that?
So, steel as a material, if you are able to recover the material, it can be reused. So, the 98% of it can be reused so that your carbon footprint which comes in the manufacturing process can largely be cut down. So, our positioning of the product is that the process what it takes for the first time manufacturing of steel is where it takes a huge carbon footprint. So now once the material is in and shaping it into a different material or use will not get that much of a carbon footprint. So 98% of the material which is already gotten, if you want to literally remove and reuse, that can be reused in a different form.
Okay. So any in this project for recyclability, any detailing which you have done consciously, or maybe you missed it, or there wasn't an opportunity and you would like to do it for the next future project?
No, there is some thought given to this, so as a company through JSSL, we always do bolted connections on site. So if this building has to be, dismantled after its life cycle, 60, 70 years, yes, the deck sheet we will have to, break through in terms of, because it's composite, but the columns, beams are all bolted connections, so it can be brought down in a sequential manner.
Oh, wow.
So you'll just lose the floor slab, but
So column beams are not really welded.
no, they're bolted,
Yeah,
all bolted connections. Also.
Splicing and bolting. Well, that's brilliant. So that's where 98%. I was a little skeptical of that number, so I asked. So, all right. So now we are looking at, it's very heartening to note, and I would open the discussion to the audience. Please, if you have any questions, please ask. The whole idea behind this panel discussion was to understand one of the award-winning entries in the SSMB awards, and of course a project based in Hyderabad. Hyderabad incidentally is a place where after I came back from the US, this was the city which I started working in, and I used to come here almost once every week because of the Shamshabad airport. And the airport air traffic control tower is something which is my personal design, and it was being shot. And I was saved by Kiran Gandhi because he went ahead and took the image and put it on the website before anybody could say anything. So ultimately everyone else had to shut up and we had to do it. It was being shot down by Arup actually, and for reasons best known to Arup and L&T because of constructability issues, which ultimately, and they were disguising it as harmonics and a whole lot of stuff. So as an architect, I learned a whole lot of structural design terminology in that project itself. But I'm very proud of it. It's not a circular floor plate, it's elliptical because I actually sat down and I mapped those sight lines of a landing aircraft and taking off, and with a parallel runway system. And after a long time, I'm coming back to Hyderabad, so it's been a very pleasant day for me. Hopefully it should end very pleasantly for all of you. So please ask questions. Whatever it is in your mind, please ask. Yes.
When you use the steel structure, you are using a reuse. The carbon content is reduced. So second time, third time, automatically the percentage will come in. What is the material property? What is the life of that steel structures?
So, upfront, I don't have that information handy to give you, but to give you a broader picture, largely once the material is coming from the wood to a steel, which is in a form of use, that process is going to take a huge carbon footprint. And when you go in terms of the reuse, that is only melting and shaping it into a different form. Now, type of requirements will have different metallurgy. You will add up something, you try to treat it in a different format. So these are all the processes which gets in. So our understanding on the material is that this gives that ability of having 98% of the material which can be reused in steel, what we use.
So just to add to that answer, we as ISCA, we are also looking at certified recyclable steel in the country. We are getting the steel ministry to get involved in it, and there will be a calculation process which will be drawn out. So what will happen is their carbon footprint, which will be initially high, the moment the steel is reused, they will get credit. And the person who's going to be using that certified recyclable steel, his initial carbon footprint will always be zero. It will be only the transportation and erection and whatever energy consumed in that which will be calculated. So for the material itself, embedded energy in the material itself will be zero. Any other? That was a very good question.
Yeah, hi, this is Diwakar.
Yeah, hi.
So how do you see
Can
the
you
role of...
introduce yourself too, so that we know who you are?
Yeah, hi, this is Diwakar from KDR Drafting Services. I am a steel detailer. So how do you see the role of a steel detailer in the steel industry for the use kind of buildings?
Sorry, I didn't get the question. If you have...
How do you see the steel detailer role in this in the steel construction industry?
Detailer, right?
Yes, steel detailer, you are right.
It's very, very bright. In fact, we need a lot of them. So we can meet, I can meet you after this meeting. But it's as you know, the steel industry is growing many folds. You must be, everybody knows the steel industry itself, like the JSW, JSPL, Tata Steel, they are growing, by millions of tons every year. And all this steel has to be consumed somewhere, and if you see the worldwide ratio, 50% of the steel is consumed in construction. But unfortunately in India, I mean, it's mostly rebar. Steel construction, like
Yeah,
the tall
it's
building.
mostly rebar, yeah, you're right.
Yeah, but it is getting consumed, but the structural steel percentage has grown by a big number in the past 10 to 12 years. I have been personally at it, and the number of projects that we win or our competitors win compared to what it was in 2010 or 12 is huge, I would say. Every year we are doing 15 to 20 projects our competitors are doing. So, it's a big industry. In fact, the industry of steel detailing is so good in India that, it's the US and the UK outsources it to India.
Yeah, you are right.
So
So we are one
it's-
of the kind.
Yes, yes. So it's very bright, I would say.
Okay, thank you.
So he was just wanting to have it reaffirmed.
I am Krishnakant Reddy from Metalcraft Farming Industries. And my question is like, there is a core with a shear wall in a steel. What is the thickness of that steel for a 40 floors or in the, how it will be like, means it will be like, that much slender member, no?
Correct.
How it will be like, what is the thickness you are using there?
Correct. So on this particular project, it started with 20 mm thick at the base, and then we went as low as 8 mm on the top. So you have to understand one thing, I understand you are thinking about 35 stories and the thickness of steel plates will be larger, but here it's a shear wall. So its primary role is to resist shear, and the length is quite adequate. Yes, it is also a gravity member for certain area, but the tributaries around the core is not large. So it's designed compositely with two plates stitched with those studs, and then we concrete infill it. So 20 mm, so effectively it's 40 mm for that particular wall. But from 20 we scale down to 16, 12, and then 10 and 8.
Okay. And during the concreting, there we have to do the watering, like curing. What are the chances of corrosion? Means it will be like for a steel, corrosion is a very
You mean on the inside face
yes,
of
inside,
the
inside.
So to start with, when we fabricate these shear walls, we short blast the steel completely from both sides and put primer on the outside. But yes, on the inside there will be mild surface rust, so it's not detrimental. As soon as it's concreted with mild surface rust, that's not a problem, because the concrete is self-compacting concrete that is poured in. If your question is regarding heat of hybridization and how the concrete cures, we give these weep holes, and it's always open from the front face or from the top face. So the heat of hydration passes. So there is a good bond between the concrete and steel.
Okay. And what is the stability life you are going to give for these structures?
As good as a RCC building. So it's designed perfectly analogical to a RCC building. So there is, like, as per our Indian codes, the 1893 we designed it for earthquake and wind. 875. So
In
there
terms
is
of
no,
years, like
In terms of-
like 20 years or 30 years.
no, it's for the actual life cycle, whatever our code specifies, 50, 60 years.
Okay. Okay. Thank you.
Yeah, that's a good question actually. So in terms of maintenance, there are, I would say, two type of maintenance in structural steel buildings you should see. If it's regarding exposed steel or interior steel. So now if you saw, or you are going to see, the building is completely cladded with glass facade. So if you see the steel that we supply, as I said, it's first cleaned with shot blasting, and then it's primed, and then it's fireproofed. So in terms of corrosion, there is enough protection that is taken for a building, for a steel that is for an interior use, because it's cladded. If it's exterior, yes, like the airports or any other roofs which are painted with either intumescent or any weatherproof paint, periodic maintenance is required, because no paint company gives, paint warranty more than 5 to 10 years. So it has to be checked. See, if there is, like in this particular building, the amount of exposed steel is very minimal. So I would say there is no maintenance cost on. No, as I said, if it is only exposed, so it will be only the lobby area or, an atrium area or a cantilever porch that you have. Or staircases, yeah. Yeah, that is also an option, but most architects won't like that galvanized look, they want the steel to be painted, and architects,
Okay, last question. I'm sorry, we are running out of time, so this will be the last question.
Okay.
Yes, gentlemen.
Regarding these cuts in the web of the steel sections, sometimes maybe the requirement of services require critical sections also we may have to cut the section. I have seen some of these people are cutting with gas cutting and again taking these pipes and all that. So what precautions you are taking to avoid at critical sections the weakness is not made?
Correct. So that's a pretty, actually, it goes back to the basic engineering, structural engineering. It is designed as per the codes where, there is certain restrictions on the size of the hole, the location of the hole. You can't have it you can't have a big square or a rectangular hole in the middle where there's maximum bending moment. And also if there is unavoidable cases where we have to stiffen the web and design the section accordingly. So there are programs and software available. Of course, ETABs are commonly used, software doesn't do. But we as JSSL, we have a software called FabSec, which we have inherited from Severfield, our parent company, which specifically deals with this, openings in the web. So, it strategically tells us where to put it or where not to, or how to thicken the web. So it's not always prudent to completely thicken the web of a 12-meter beam, but locally strengthen a joint. But there are certain do's and don'ts, and there are international codes like the UK Euro or BS code and the SCI publications that give good guidelines on this.
Just to, so there would be no ad hoc cutting on site.
You won't allow it.
That has to go through me. So heaven forbids that the architect and engineers didn't coordinate, and we would have to, and we missed out cutting. We would have to go back through the structural engineering, both from the engineer point of view and JSL, to make sure what we can cut, and then as Prasad said, how we would fill in around it, make sure we strengthen that particular cut.
Thank you very much, gentlemen.